Cisco DMVPN. Hi, my name is André. I'm here today to talk about DMVPN. On this first video, we will have a little knowledge to how to create a tunnel interface to be used in DMVPN solution. We have here on this first slide the agenda. On part 1, we will talk about what is DMVPN, flowchart that will guide us how to implement this DMVPN interface tunnel, an example of a front VRF scenario, and for last, question and answers. DMVPN, Dynamic Multipoint Virtual Private Network. This is what the DMVPN acronym means. Usually used to protect the corporative data, these solutions make use of an underlay network infrastructure that can be MPLS or the Internet clouds. You can read on this slide a brief description. Here's the slide with the flowchart steps. The simple flowchart can give us a notion about how the DMVPN will work. First of all, we will need to be sure that our underlay network is fully active and that all sites that will receive the DMVPN solution can reach each other. Looking the flowchart, we go to a second step, create the tunnel interface followed by the IPsec parameters. To finish, we should apply this IPsec on the tunnel interface. DMVPN implementation steps. We have here an example with one RUB site and 4 spoke sites. Let's see if the underlay is working fine. You can see the connectivity between all sites is properly working. It's working fine. So that's great. All sites can reach each other, so we can move to the next step. Now we have here examples how to configure the interface tunnel. You can see this tunnel interface on red for the RUB site and blue to the spoke site. Okay. You should pay attention on the IPMTU and the IPTCP adjust MSS commands. IPMTU 1400 will prevent fragmentation when IPsec and GRE overhead be applied. And the TCP maximum size fragmentation should be 40 bytes less than IPMTU to avoid truncation. Tunnel source interface should be the underlay interface, and the tunnel destination command is not used. In his place, we use the tunnel mode GRE multipoint. Here we have the next hop resolution protocol. It will, This protocol, it will build tables where the overlay IP is correlated with the underlay IP. All this work is done by the RUB, and it is shared with the spokes that we call Next Hope client, and the hubs we call it as Next Hope server. Here we have a few comments to implement the Next Hope resolution protocol. The IP NHRP network ID command. It's a command that will enable the NHRP on the interface and create a NHRP domain. This network ID or domain number is the local significant, so it is not forwarded on NHRP packets to other routers. Despite the network ID can be different between the routers that are participating on DMVPN Cloudy, the best practice is to use the same network ID on all routers to a better troubleshooting and to track which GRE interface is member of what NHRP domain. On old iOS versions, we should told the RUB router that he is the NHS router too. So we should add this static mapping using the command IP NHRP NHS and IP NHRP map. You can see on the slides an example in yellow and in blue for old iOS versions of commands. Remember that NHS is Next Hope server, that's always the hub, okay? On this other device slide, we have another few NHRP commands. We can see here the IP NHRP hold time, that is how long the Cisco iOS software tells other routers to keep the address mappings in its providing in NHRP response. This controls how long the spoke-to-spoke shortcut path will stay up after it's no longer used, or how often the spoke-to-spoke shortcut path mapping entry will be refreshed if it is still being used. We recommend that the value from 300 to 600 seconds be used. The second command is registration timeout. If not configured, the default is 1/3 of the hold time. It is the time frequency that the routers should refresh the registration with NHS router via NHRP registration requests. The third command, registration no unique, use it only on spoke routers, okay, apply on spoke only. It is necessary in case since the spokes outside IP or the underlay IP addresses may change at any time. Usually used on ADSL links of internet. This will permit the RUB overwrite the NHRP map with the new spoke address. Authentication string is only routers configured with the same string can communicate with each other. And if state NHRP. This on the spoke routers detect if the Next Hope server is down and put the interface tunnel down. When detected the next hop server is up, it puts the interface in up state again. Here we have the IP and HRP redirect on the RUB side and IP and HRP shortcut on the spoke side. So the redirect command tells to the spoke routers when there is a better path to use, and the shortcut make the spoke router choose this best path shortcut to the somewhere, permitting a spoke-to-spoke temporary connection. So this redirect command will make the RUB teach the spoke router a new and better way to reach another spoke. And the shortcut command will make the spoke router choose and use this new way. For on this slide, we have configuration to implement multicast on the tunnel interface. So you will need work like any other interface and complement the configuration with IP ping, sparse dense mode or sparse mode or an IP and HRP map multicast dynamic. This is an important command that should be used. You can see here too on old iOS versions it's needed we use the map multicast command pointing to the next hop server. Remember that some routing protocols make use of multicast. So probably you should use these commands in many implementations. So after we configure our interface tunnel, let's see if everything is working properly. We can see the connection between the routers using the tunnel interface here. You can see the green line is the temporary tunnel between the spoke routers, and this is possible because of the commands redirect on the RUB side and shortcut on the spoke side. The DMVPN phases are three. Phase 1 is the communication between the spoke and the RUB. Phase 2 is the communication between the spoke and another spoke, but using the RUB as a bridge. And phase 3 is the direct communication between spoke and spoke. This is possible using the command redirect and shortcut. For last, we have here an example of a tunnel interface using a front VRF. So you can see the configuration, IP VRF forwarding, that is the customer, and on tunnel VRF internet because our underlay interface is part of the internet VRF in the router. here we have the question and answers. You can send me questions by email or call me on Skype for Business, and I will answer you as soon as possible. You can find more material on ablongbr.blogspot.com.br. So we finish his first video here, and I will create another video, a second video, where I will spoke a little bit about the IPsec to be implemented on Tunnel interface. Thank you very much. Bye bye.